Alright, now we will look at how to solve the real-life problems in an actual test. To integrate the functions of this calculator and the real-world problems, we would optimize, for example, optimize the design for a container, or using calculus to minimize the surface area for a given volume, which has the applications of in manufacturing and design. So by using the method that I just taught you, you can make these calculations straightforward. And by inputting the necessary equations and constants, we can quickly find the optimal dimensions. For example, if we want to find a maximum volume of a box, then we should write the volume equation. And then we find the maximum of this function by using the graphing tools, which I'll show right now. Right now, you can see we're still in the calculation page, but if we click this button on the left of the calculator, we would exit the scratchpad and we would enter the graphing function here. For the simplicity of this demonstration, I will input x to the power of 3 plus x squared. I will set this, for example, as the Vx function, the volume. Now, if we press enter, we graph this out. So normally the problem would ask you to find the maximum over a certain interval. So how do we find that interval? It's usually given in the question. So on the graph here, if we want to find the maximum, we would use function like the analyze graph function. And under this drop-down menu, there are many choices. We would choose the maximum function. Choose the maximum. I will ask for a lower bound. Just move your cursor to the lowest point that you wish to investigate, and then drag it towards the upper bound. Then it will display the coordinates of the maximum point in this interval. This is an example of how to use the graphing function to solve a volume-related question in the exam. Thank you very much.